All right, hello everybody. So this is our working on function transformations and really trying to bring it together in the study guide. And so some of these questions are going to tell us exactly what type of function transformation to do, and then we just need to get more specific with it. So like on question 1, we're determining the value of k so that g of x equals f of kx. So when the k is on the inside, I know it's horizontal, and when it's multiplying, I know it's a horizontal stretch. Okay. So what I'm going to do is just basically figure out how much wider we have to go here. Okay. So what I notice is that I have a point of 10 comma 0. So that what that means is that f of 10 is equal to 0. And I also have another point here, which is 30 comma 0. So I know that g of 30 is also equal to 0. So then what I can do is I can write that down as one equation. F of 10 is equal to g of 30, right? And what I want is I want f of something times x. So I want to make the number that is inside of g. See, g has the number x inside of it. I want that to match up in f. And so what I'm going to do is I'm going to think f of something times 30 equals g of 30. And it turns out that I can do a third times 30 because I need to make k times 30 equal to 10. The original equation was f of 10, so I need to make 10 equal k times 30. So anyway, k equals 10 over 30, k equals 1/3. What this means is that the dotted line, f of x, is a third as wide as the solid line. Okay, let's look at the next one here. Same sort of idea on the second question here. I've got f of 3.125 is equal to g of 5. So I need to figure out k times 3.125 is equal to, oops, sorry, I have that backwards. I want to figure out, because what I want is I want for f of kx. So I'm going to take I'm going to take this to match up with g of x. So what I'm going to say is 5 equals 3.125 times k. And so then I have 5 divided by 3.125 is equal to k. And so what that means is g of x is equal to f of 5 over 3.125 of x. All right. Then going down and to the right here, we have these points that were given. We have f of x is the dotted line. Is the dotted line here? They keep switching it around. That's kind of confusing. So f of x is the dotted line here. So I know that f of 0.693 is equal to g of 0.277. I want g of x to equal f of k times x. Okay, so I want to figure out k times 0.693 equals 0.277. And so k equals 0.277 divided by 0.693. And then the last one here, I have that f of 4 is equal to 2, and g of negative 8 is equal to 2. So I want g of x to equal f of kx. So I want k times 4 to equal negative 8. So what I'm noticing is that k is equal to negative 2. What that means is two things, that it's flipped over and it's twice as narrow. Okay? So it's a little bit tricky, in my opinion, with the horizontal dilations. I often get switched around in my head with what way they're going, but I think that the vertical dilations are a little bit easier, which are like these questions over here on the right side. So for example, express g in terms of f using function notation. G of x here is equal to, well, I'm looking that they have the same x value of 11. The y value is different, where the y value of f is negative 121 and the y value of g is negative 55. So I can just go negative 55 over negative 121 f of x. What I'm doing is I'm just taking the value that I want, the new value, divided by the old value. So similarly here, I see that if I want g of x for number 2, it's going to equal something times f of x. The old f of x value is negative 8, so I'm going to divide by negative 8. And the new value that I want is negative 13.6. So I'm going to multiply by negative 13.6. Same sort of idea here. G of x. I want g of x to have a value of negative 12.5. My f of x has a value of negative 50. So I do that. And on the last one, g of x is equal to, I want g of x to have negative 1.5. F of x has 6. So I write it like that. Notice again that the negative is going to flip it over. So that's it for the first page. Again, please just let me know if things are confusing, and I'll try to explain it. Or if I think I made a mistake, it's always possible that I mix things up. All right, describe the transformation here. So I noticed two things in part A. I noticed the negative is a vertical reflection because there's a negative in front of it, and it's a vertical translation going up by 2.7. Kind of abbreviating here because this is a sort of small space. So that's it for part A. For part B, there's a couple different things going on. This time the negative's on the inside, so that's a horizontal reflection. There's a plus 3.1, so that's a horizontal translation left 3.1, and there's a plus 1 on the outside, so that's a vertical translation of up 1. For part C, there's only one thing going on, vertical translation down by 26. And for part D, looks like there's two things going on. There's a vertical reflection because there's a negative symbol in the front, and there's a horizontal translation going right by 0.004. All right, number 3, write an equation, parabola, vertex at 1, 4. So I know that it's shifted right by 1, and it's shifted up by 4, and it needs to open upward. So this opens upward, so does this, so does any positive number in the front. Now, if I want to make a parabola have a vertex at 2, negative 3, I do this. And if I want it to open downward, I put any negative number in front of it. All right. Now, number 4. The function f is odd. And odd means that the positive side is the opposite of the negative side. So this is rotational symmetry. This one is not true because this says that the positive 5 is equal to the negative 5. Not true. Part B is true because positive side is 3, negative side is the opposite. Reflection over the y-axis takes it to itself. No, that's true for even. Reflecting f across both axes takes the graph of f to itself. That is true. That's what odd means. And then the last one, f of 0 equals 0. Well, think about if it didn't for a second. Think about if we had f of 0 equals 5. Then we would reflect that over the y-axis. That doesn't do anything. And then we'd reflect it over the x-axis, and that would mean it's down there. So that is actually, it has to be true that f of 0 equals 0. Because if it wasn't true, then you would have two different dots on the y-axis. That's kind of interesting. All right, number 5. Here's a graph for negative 10 to 0. Sketch for 0 to 10 if it's even. So I'll use red for even. Even means it's going to be the same shape. So imagine I drew that perfectly symmetrical. And I shouldn't have put an arrow on the end because it just says to go between 0 and 10. So we'll just cut it off right there. So I drew that perfectly symmetrical. If f is odd, then it's going to be the vertical flip of that. If f is neither even or odd, then I can do whatever I want on that side. Okay, again, let me know if things are confusing. Happy to help out. Okay, now we have a table with some f and g things. Which of these equations could be true for all values of x? So I'm noticing here, let's see, that let's try to write out a couple statements. I notice that f of negative 2 equals 4, and I'm noticing that g of positive 2 is equal to 4. I'm noticing that f of negative 1 is equal to 2, and g of positive 1 is equal to 2. Okay. I'm noticing that g of negative 2 is equal to 1/4, and f of positive 2 is equal to 1/4. So really, each of the negative inputs matches with the other graph's positive inputs and vice versa. So I think that means this one right here is true, that f of x is equal to g of negative x. Because when you switch the negative to the positive x, then it switches from being an f of x to a g of x. This first one's not true because this is talking about f of x having negative y values of g of x. This third one also has negative y values, and this fourth one says that they are always the same. So it looks like part B is the only one. Okay, now we're going to describe a transformation of the line that contains the two labeled points. So I think that what we got to do is we got to move this line up, looks like 3 steps. So vertical plus 3. And then what was our slope? Our slope is going up 1 over 2. So if we did that, up 1 over 2, up 1 over 2. So we would miss that other point right there. So then what we can do is we can stretch it out here. So instead of going up 1 and over 2, why don't we go up 1, 2, 3 and over 1, 2, 3? Okay, so what we're going to do is we're going to take our old function. So let's say f of x is the old function. We're going to take f of x. We're going to go plus 3 to it. And then we're going to stretch it out. It used to go up 1 and over 2. Okay, and we want it to go up 3 and over. Did we say 3 as well? Yeah, and notice that going up 3 and over 3 is the same as going twice as steep as the other one. The reason I know that is because 3 over 3 is equal to 1, and that's equal to 2 times my old slope of 1 over 2. So I can put a 2 right here, and then this is going to be my new line. Twice as tall vertically and 3 steps higher. All right, last page here. We got a tennis ball. We got a lovely little equation right here. How high was the ball when it was hit? That means I'm going to plug in t equals 0 because t means the time after it's been hit. So if I plug in t of 0, that means I'm plugging in 0. So I've got 5 plus 30, plug in 0, minus 32, plug in 0. Plugging in 0 just gets rid of all that junk there. So it's 5 feet high, which represents the y-intercept right there. Okay, part B. Suppose the second ball follows the same trajectory but is hit from 7 feet off the ground. Okay, so I'm going to sketch that. It's just going to look basically the same as this. Just I'm trying to draw another parabola that's parallel, just 2 steps higher all throughout its path. And I know that g of t is just going to be old f of t plus 2. And so that means that I can write a very specific equation because I'm just adding 2 to the old equation. Notice that adding 2 only affected the 5 because the other two values have t in them. It's not like terms. All right, last one, transforming graphs so it goes through the labeled point. This parent graph is x cubed, and I can see that it needs to go left by 1 and up by 1. On part B, this looks to me like a 2 raised to the x pattern. No, a 3 raised to the x pattern maybe? Kind of hard to see exactly. Maybe it's an e raised to the x pattern because it looks like it's going between 2 and 3. We'll pretend it's e raised to the x. And it looks like it went 1 step to the left and it went 1 step down because I'm taking this point of 0, 1 and bringing it left 1, down 1. I think that's the only point I had to hit. Okay. Part C, I'm going to take my parabola and I'm going to move it 2 steps to the right and 4 steps down. Part D, it just looks like I need to make it either twice as wide or half as tall. Either way, I'm going to do 1/2 and then in front of the absolute value of x. So there's the study guide. Again, please comment and let me know what I can do to help.